Good morning, students. So today's class we are going to study about the FIR filter design problem using windowing technique. So the given problem is we need to design the ideal high pass filter with a frequency response H3 of e power j omega equal to 1 for modulus of omega varies between pi by 4 to pi and 0 for modulus of omega less than or equal to pi by 4. We need to find out the values of h of n for n equal to 11 and find h of z. Then we need to plot the magnitude response using Hanning window. So we know that the Hanning window function is WH of n equal to 0.5 plus 0.5 cos 2 pi n by n minus 1, where small n varies between minus of n minus 1 by 2 to n minus 1 by 2. So we have to substitute n equal to 11 in the above formula. So when you substitute n equal to 11, the formula becomes 0.5 plus 0.5 cos 2 pi n by 10, because n value when you substitute 11, it will be 11 minus 1, it is 10. For small n value also varies between minus pi to pi. Now in this equation, we have to substitute the n value varies between 0 to 5, and according to the symmetricity, and 1 to 5 will be equivalent to minus 1 to 5 minus 5. So we will be calculating the values for it. So WH of 0 equal to 1 and WH of 1 is 0.9045, WHN of 2 is 0.655, WHN of 3 is 0.345, WHN of 4 is 0.0945, and WHN of 5 is 0. So after calculating this window functions, then we have to go apply the inverse Fourier transform to this particular formula. And here the omega value is modulus of omega, so it holds minus plus sign and also minus sign. So if the omega is positive, the limit will be pi by 4 to pi. If the omega is negative, the limit will be minus pi to minus pi by 4. So here we will be substituting minus pi to minus pi by 4 for negative value and plus pi to pi by 4 for the positive value and integrate. So after integration, we will be getting that expression as um, sin pi n minus sin pi by 4n divided by pi n. After that, we have to substitute for Hg of 0. It is after substituting the L dash hospital rule, you will be getting 0.75. For Hg of 1, it is 0.225. You will be using this formula to find out the Hg of 1 to 5. And Hg of 2 is minus 0.159. Hg of 3 is minus 0.075. Hg of 4 is 0. Hg of 5 is 0.045. And the same value for negative values of Hg of minus 1 to minus 5 will be the same for Hg of 1 to 5. So next we have to multiply the inverse Fourier transform expression with the windowing function. So after multiplication, we will be getting the h of 0 as 0.75, h of 1 as minus 0.204, h of 2 as minus 0.104, h of 3 minus 0.026, h of 4 is 0 and 5 is 0. Next, we have to implement in the transfer function h of z equal to h of 0 plus summation n equal to 1 to 5 h of n z power minus n plus z power n. So we can expand this by substituting the n value varies between 1 to 5. So we are expanding this in this next equation. So h of 0 plus h of 1 z power 1 plus z power minus 1 plus z power 1 plus h of 2 z power minus 2 plus z power 2 plus h of 3 z power minus 3 plus z power 3 plus h of 4 z power minus 4 plus z power 4 plus h of 5 z power minus 5 to z plus z power 5. Now in this equation, after substituting this h of 0 values, you will be getting the h of z expression as 0.75 minus 0.204 z power minus 1 plus z power 1 minus 0.104 z power minus 2 plus z power 2 minus 0.026 z power minus 3 plus z power 3. Then the transfer function of the realizable filter is given by h dash of z is z power minus 5 into h of z. We need to multiply the h of z with z power minus 5. After that, arranging in the order of z power, the smaller order to higher order. So it will be minus 0.026 z power minus 2, minus 0.104 z power minus 3, minus 0.204 z power minus 4 plus 0.75 z power minus 5, minus 0.204 z power minus 6, minus 0.104 z power minus 7, minus 0.026 z power minus 8. Then we have to implement the magnitude function, which is given by h of e power j omega equal to summation n equal to 0 to n by 2 minus 1 a of n cos omega n. So we'll be expanding it, substituting n equal to 0 to 11 by 2. It is n minus 1 is it is n value 11 minus 1, it is 10 by 2, 5. So we'll be expanding this by substituting n equal to 0 to 5 in this equation. When you substitute the n value, it is a of 0 into cos omega 0 plus a of 1 into cos omega plus etc. a of 5 into cos phi omega. Now, in this, we have to find out the value for a of 0 and a of n. For a of 0, the formula is h of n minus 1 by 5, 1 by 2. In that n is equal to 11, when you substitute, it will be h of 5. So, which is equivalent to 0.75 according to this particular equation. Then, the next step is we have to find out a of 1. For that, the a of n formula is 2 into h of n minus 1 by 2 minus n. When you substitute 1 here, it will be 2h of 5 minus 1, 2h of 4. So h of 4, according to this, it is minus 0.204. We'll be substituting it multiplied with 2 and find out the value. So it will be minus 0.408. Then for a of 2, 2 into h of 5 minus 2. That means 2 into h of 3, which is minus 0.104. We'll be substituting here. So like that, we'll be, when you substitute, you will be getting this values. After that, we will be substituting this a of 0, a of 1 values in this equation. So you will be getting the magnitude function equation as h bar of e power j omega equal to 0.75 minus 0.408 cos omega minus 0.208 cos 2 omega minus 0.052 cos 3 omega. So in this, you have to substitute the various value of omega varies between 0, 30, 60, 90, 120, 150 and 180 and find out the value for h of e power j omega. So when you substitute the omega as 0, you will be getting the value as 0.082. When you substitute the omega value as 30 in this equation, you will be getting 0.292. So similarly, you have to calculate till 180. After that, you need to plot it, the magnitude response by marking omega in the x-axis and modulus of h of e power j omega in the y-axis. So you'll be getting this particular transfer function. So this is an high pass filter multiplied by the Hanning window. You will be getting the response like this. Thank you.